Conduit fill calculators are essential tools for electrical installations, ensuring that the wiring within a conduit complies with the National Electrical Code (NEC) regulations. These calculators determine the percentage of the conduit's cross-sectional area that is occupied by conductors, which is a critical factor in preventing overheating and ensuring the safety and reliability of the electrical system. Several online resources are available to assist in performing these calculations. Firstly, Conduit offers a conduit fill calculator on their website. Secondly, Calculator. Net provides an electrical conduit fill calculator. Thirdly, Easy Calculation. Com features a conduit calculator. Lastly, Calculator. Org offers a conduit volume calculator. These calculators generally require inputting specific information about the conduit and the conductors to be installed. The key parameters include the inner diameter of the conduit and the size and number of conductors. Conductors are typically specified by their American wire gauge (AWG) size, such as 12 AWG 10 AWG or 8 AWG, and their insulation type, such as THHN or THWN. The conduit's inner diameter is crucial because it determines the total available space within the conduit. The NEC specifies maximum fill percentages to prevent overheating and allow for future expansion. The fill percentage is calculated based on the total cross-sectional area of the conductors and the inner cross-sectional area of the conduit. The NEC guidelines vary depending on the number of conductors within the conduit. For example, the maximum fill percentage for a conduit containing 2 or fewer conductors is typically higher than that for a conduit containing 3 or more conductors. The NEC also provides tables that list the allowable fill percentages for different types of conduits and conductors. Conduit fill calculators automate these calculations, providing a quick and accurate assessment of whether proposed wiring configuration complies with NEC requirements. These calculators typically present the results as a percentage of conduit fill. It is important to use a reputable and up-to-date calculator to ensure compliance with the latest NEC standards. Using an outdated calculator or inaccurate data can lead to incorrect fill calculations and potential safety hazards. In addition to online calculators, there are also mobile apps available for conduit fill calculations. These apps can be particularly useful for electricians and contractors working in the field, as they allow for on-the-spot calculations without needing to access a computer. When using a conduit fill calculator, it is essential to input the correct information. Common mistakes include using the outer diameter of the conduit instead of the inner diameter, or incorrectly identifying the AWG size or insulation type of the conductors. It is also important to consider the directing factors that may apply to conductors in certain situations. Directing factors are adjustments to the allowable ampacity of conductors based on factors such as the ambient temperature and the number of current carrying conductors in a conduit. These directing factors are specified in the NEC and must be taken into account when determining the appropriate wire size for a given application. For instance, NEC Table 310.15 B3 provides adjustment factors for ambient temperature, and NEC Table 310.15 B3 C provides adjustment factors for the number of current carrying conductors in a raceway or cable. The ampacity of a conductor is the maximum current it can carry continuously without exceeding its temperature rating. The NEC specifies ampacity ratings for different types of conductors based on their size and insulation type. It is crucial to select conductors with ampacity ratings that are sufficient for the intended application, taking into account any applicable directing factors. Overloading conductors can lead to overheating, insulation damage, and even fires. In addition to conduit fill calculations, it is also important to consider the physical space requirements for conductors within enclosures. Enclosures are boxes or cabinets that house electrical components such as circuit breakers, switches, and terminals. The NEC specifies minimum spacing requirements for conductors within enclosures to prevent short circuits and ensure proper ventilation. These spacing requirements vary depending on the voltage and current levels of the conductors. It is also important to ensure that enclosures are properly sized to accommodate the conductors and components they contain. Overcrowded enclosures can lead to overheating and difficulty in accessing components for maintenance and repairs. When installing conductors in conduits, it is essential to use appropriate pulling lubricants. Pulling lubricants reduce friction between the conductors and the conduit, making it easier to pull the conductors through the conduit. They also help to protect the insulation of the conductors from damage during the installation. There are various types of pulling lubricants available, and it is important to select a lubricant that is compatible with the type of conductors and conduit being used. It is also important to follow the manufacturer's instructions for applying the lubricant. Over-lubrication can make it difficult to grip the conductors, while under-lubrication can increase friction and make pulling more difficult. When pulling conductors through long runs of conduit, it may be necessary to use pulling equipment such as a fish tape or a rope. Fish tapes are flexible metal or plastic tapes that can be inserted into the conduit to guide the conductors. Ropes can be used to pull the conductors through the conduit, especially for larger conductors or longer runs. It is important to use appropriate pulling techniques to avoid damaging the conductors or the conduit. Excessive pulling force can cause the conductors to stretch or break, while improper handling can damage the conduit. After installing the conductors in the conduit, it is important to properly terminate the conductors at the electrical components they will connect to. Terminations must be made securely and in accordance with the manufacturer's instructions. Loose or improperly made terminations can lead to overheating, arcing, and even fires. It is also important to ensure that the terminations are properly insulated to prevent short circuits. In addition to conduit fill calculations and proper installation techniques, it is also important to regularly inspect and maintain electrical systems to ensure their continued safety and reliability. Inspection should include checking for loose connections, damaged insulation, and signs of overheating. Maintenance should include cleaning enclosures, tightening connections, and replacing worn or damaged components. Regular inspections and maintenance can help to identify and correct potential problems before they lead to serious safety hazards. Conduit fill calculations are just one aspect of ensuring the safety and reliability of electrical systems. It is also important to have a thorough understanding of the NEC and other applicable codes and standards. The NEC is a comprehensive set of rules and regulations governing the design, installation, and maintenance of electrical systems. It is updated every 3 years to reflect changes in technology and best practices. Staying up to date with the latest NEC requirements is essential for anyone involved in electrical work. In addition to the NEC, there may be other applicable codes and standards depending on the location and type of electrical system. For example, local building codes may have additional requirements for electrical installations. It is important to check with the local authorities to determine which codes and standards apply to a particular project. Electrical work can be dangerous, and it is important to take appropriate safety precautions. Always disconnect power before working on electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. And never work on electrical equipment if you are not qualified to do so. If you are not comfortable working on electrical equipment, hire a qualified electrician. Working with electricity can be a rewarding and challenging career, but it is important to take the necessary steps to ensure your safety and the safety of others. By following the NEC and other applicable codes and standards, using appropriate tools and techniques, and taking necessary safety precautions, you can help to ensure that electrical systems are installed and maintained safely and reliably. Remember to always consult the latest edition of the NEC and local codes for the most up-to-date requirements. These codes provide detailed information on conduit fill, conductor ampacity, grounding, bonding, and other essential aspects of electrical installations. Understanding and adhering to these codes is crucial for ensuring the safety and compliance of any electrical project. For example, the NEC specifies the types of conduits that are permitted for different applications, such as rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Each type of conduit has its own advantages and disadvantages, and it is important to select the appropriate type for the specific application. The NEC also provides requirements for grounding and bonding electrical systems. Grounding is the process of connecting electrical equipment to the earth, which helps to protect against electrical shock. Bonding is the process of connecting different metal parts of an electrical system together, which helps to ensure that they are at the same electrical potential. Proper grounding and bonding are essential for preventing electrical hazards. The NEC also includes requirements for overcurrent protection, such as circuit breakers and fuses. Overcurrent protection devices are designed to protect electrical circuits from damage caused by excessive current. It is important to select overcurrent protection devices with the appropriate ampacity rating for the circuit they are protecting. In addition to the NEC, there are also other organizations that provide guidance and training on electrical safety. For example, the National Fire Protection Association (NFPA) offers a variety of resources on electrical safety, including training courses, publications, and codes and standards. The Institute of Electrical and Electronics Engineers (IEE) also provides resources on electrical engineering and related topics. Staying informed about the latest developments in electrical safety is crucial for anyone involved in electrical work. By continuously learning and improving your skills, you can help to ensure that electrical systems are installed and maintained safely and reliably. And remember, when in doubt, consult a qualified electrician.